Yeah, hello everyone. And this is the video title. Today I will to guide you, show you how to configure the CAN Classic in the in the STM S743 VET6. Yeah, I find a lot of video in the internet. Currently, this chip just supports the CAN FD flexible frame, flexible data. It means and yeah, it supports the classic frame also, but I cannot find any tutorial in the internet like the Google, YouTube to to show how to configure the classic frame in there. So today today I will to show you how to configure it. The first thing I will to configure to the I enable to debugger. I use a 0Y and configure to the system text and clouds. I use the internal clouds, and after that I config enable can FD, yeah, in here. In my case I want to, if in the PB9 PBS I will switch pin for the can tick and can RS. Yeah, after config successfully I config to the cloud. I switch to the SSC eternal clouds, and I want to use the cloud is the maximum for 8 zeros. Yeah, it will be take a little bit time to calculate the cloud for the KNFD. So, but the cloud should be switch to the internal cloud. I will take to here to switch to the external clouds and reconfigure the cloud again. Yeah, after the tool calculates the cloud successfully, you can see here the the clock for the can FDCAN is 120 megahertz, but can be just support below the 100 megahertz. So I need to manually to calculate the clock for the FDCAN again. In there, I will switch to the I use 01 divide to the I will divide it to the 12, and so in there I have the 18 18 megahertz for the FDCAN. So uh, for the config the FDCAN, I will switch to the pinout and configuration, take to the CAN FD, active it, and after that I will to the parameter setting, and we have some change in here. The first thing The first thing is I will be use the frame format is a classic frame with the normal mode. Uh, and yeah, about the timing, we have the we have the we have the website for to config it. Yeah, in there I have the website is the config will support us to config to configure the CAN FD. Uh, in there we have we delete this zero one and create the new one for it. The clock frequency is the clock source for the FDCAN. In there we configure is 18 megahertz. So it switch to the kilohertz is 80,000. Clock tolerance is the difference for the clock I will always use for 687. Uh, for the node delay is mean for the CAN transceiver. In there I use the CAN transceiver is the MCP 2551. I will check it in the datasheet and search the keyword. Uh, delay it. Yeah, I will feel the maximum delay is for 400 nanosecond. I will filter here. Sorry, 01. Is 40 nanosecond at the new CAN device. Yeah. After that, we will configure to the bit rate. Is there I just use 500 kilobits. So I don't want to use a switch bar rate switch the bar rate feature in the canopy. So I will use the same bit rate and click here to recalculate again. Yeah, we have the calculate value in there, but some uh, some values are not fit for the config like here because the time segment mode, if I remember, is not support. You can see range the data time sec run just support the value between 1 to the 32. So I will recalculate for the I will switch the value to this simple point to the 7%, 75%. And prescale for the data, I will introduce to it. And prescale to the normal, I use 4. So this is the better the config value I use. Yeah, I go to the field, the config value to the first normal in there. The first thing is the normal sum up with this value. I will fill here is a 5. Data prescale I used in there is at 8. Data sum up with is the 5. Data times segment more segment is a 14. 14. 2 is a 5. Second one is a 5. Yeah. Because in there I just configure the one canopy and I just need to configure to RAM offset and one buffer. I just configure it once and just one I use 154 for the eyes, and in there I use a classic frame and the maximum data field is a S by and the KNFD the maximum data field is a 64 by. Yeah, in this guy I use a can classic, so I will configure the frame data field data field is S by, and this one in there for the one buffer for the eyes and one buffer for the TX TX side and it by also. Yeah, in there I will configure the last one. For the normal scale is a 4, and that's a segment. That's a segment one, and normal segment one, and time segment one is the fourth, and then 34 and 5. Yeah, I can put here is 34, and here is a 5. So I have the 500 kilobit right here. And for GPIOs, I switch to the fast. Sorry, maximum speed is very high, and yeah, everything I think look it be okay. So I will save to resend the new code for us. So in there, the first thing I setting the TX size. Is there I configure the TX header, transmit header, FDCAN, TX header, type and I define the new variable TX header, and I create the buffer for the transmit side. And TX and for the start the FDCAN, I use the API, and I have to check the return value for it. If and FDCAN start, but FDCAN once here, if not equal to the hand, okay. So where we may jump to the error handler. Okay, I have start to the FDCAN. After that, I need to init to the header. I configure to the TX header. The first thing is the identifier. ID going to present in the burst. I use in there the 1, 2, 3, for example, and the is just the ID type. In the can support the two types, the 11 bit and 19 bit. In there, if the three number is the 11 bits, is the standard ID can standard ID. One thing is the extended header, TX frame type is the TX header. Data layer. You can switch this config to the config how many byte you want to send to the burst. In there, I want to store one of the frame own up data field, so I will fill here is by FDCAN DLC data length codes by it. Yeah, and the header error state indicator the header dot bitrate switch. I don't use the bitrate switch in there, so bitrate switch off. FDCAN classic there. And I need to the data also for the different data for the field. You need to is you need value for each first. No, I think I do it in the for loop. Gh. Sorry, I mean in here. Just put it to zeros. E plus one. Yeah, I think. Okay, you need for the frames. So after that, maybe in there before the send, I will increase the data. Yeah, okay. And after that, we transmit it. And MD can add message to the I buffer. Is the TX header and take data. So I want to delay it. Everything look okay. So I build the project, and in there I set up. No, no, it not the error indicator, error state indicator. Okay, I can correct it and review again. Okay, it can build. It's finished build. I have in there. I have the I have the cable to monitor the frame sent to the bus. Yeah, I will set up it. State measure. Sorry, I think I will start it again. Oh, oh my gosh, it can realign my device. What happened? Yeah, I have the cable in there. I have the cable in there, and I set up it in the config, and the power rate is like that. And I flash the software to the STM kit. Setup, I use the etching and watch the data stored in there. Yeah, you can see here I had, yeah, this is the timestamp, is the delta time between the uh to continue send. Here I click auto scroll. Okay, I can send succeed to the data to the bus. So for the next side, the first thing I need to do is to declare the header FDCAN RH header and buffer to receive it. I copy this one and paste to there. Change right. And for enable yeah, this one for enable the interrupt for the receive side and FD can active notification. Okay. Is the FD can the state to active interrupt. I mean in there I want to active interrupt when the new frame receive new message. Yeah, I want to interrupt in this guy and buffer I use buffer index. I use buffer index zeros. Yeah, I think it's okay. I want to check the reasoner in. Okay, zero one is the active interrupt and the callback function you can find in here. So IT how control or how control. Sorry, I forgot to enable interrupt in the config. You into NV setting and sorry, not the one is the NV. For the FDCAN Chrome, as you can zeros, I want to enable buffer Chrome, buffer zeros. Yeah, I mean priority on and then code again. Yeah, you can find here the handler for the interrupt for the FDCAN. How mm, in there you can find the function. Yeah, this one hand FDCAN RH FIFO callback. This is was it one for the FIFO ones, and I want to find the FIFO zeros. Okay, copy 01 and paste it to the main functions. Hmm. In there, I check the interrupt status because I want to filter the new message. I can use this flag and it with the flag FDCAN IT X V4 new message V40 new message. It's the same when I configure it there and I copy the frame receipt and message and fill the FDCAN HV4 zeros and is header data is data. Okay, load is okay and I reach the code to enable the interrupt again for the next time. Okay, it's look okay. I build it and flat it to the M0. Yeah, and I want to show you the data, so I will switch to the debug mode. I paste the right data here and the header after that. Yeah, I start the software and you can see here. Oh, I have some issue in here. With me a minute. Oh, no, no problem in here. Sorry, my bad. So, yeah, you can configure same with me, and you can see here the frame still sent to the bus, and I have some example in here. I can say change the DLC and change the CAN ID 123 or for like that, and yeah, the data will be sent to the MCU. I hit the send. Here you can see here is the 11 in the hexadecimal format, and this is the identifier. This is the decimal, and the data sent here is the hexadecimal format. So it's a little bit different. So you can see I can send the data. The data length you can present here, and after that I send a through by. Yeah, it should be to the two. Huh. Okay, I'm the finished with the demo how to configure to the classic frames and every can. So thank you for the watching, and if you feel the video is helpful for you, please like and subscribe. This is the motivation for me to create a new video in the future. Thank you so much.